So the first GQL manifesto was declarative. It said, what should be in such a language, a graph query language, and about, we wanted to draw on existing languages. GQL should be the SQL of graphs in terms of the sort of ecological niche that it occupied. It should exploit work that had already happened, or in the shape of GXPath, or was happening in terms of SQL PGQ on extending graph pattern matching beyond what you could see already in Cypher and PGQL. The need for, or the desirability of, composable queries, graph construction or projection, as foreshadowed by GCore. And it should deal with mutation as well as reading, unlike PGQ. So PGQ kind of is I view it as a gateway drug for GQL. It gets you interested, and then you wonder what you want to do to actually maintain your graph. It sort of poses the question. And I'll come back to that. And then the need for schema, the need for a catalog, the need for multiple named graphs, these things have been referred to. Now, if we look at what we're actually going to get, and I've dynamically adjusted this to be GQL 2024 on the basis of what Keith was saying. Standard declarative graph query language is most definitely coming. It is very firmly in the world of SQL. It's in parallel with SQL, which I think is actually an incredibly important point about GQL just on its own, the fact that it actually is a partner or a twin to SQL. Graph pattern matching work is highly advanced, and although there are things that could be done, as Petra was pointing out, that go further, I think that that's a very sort of deep extension that's already occurred. As Peter has highlighted with his questions, the issue of the composability of the language is a major gap. I should say about all of this, this is not about criticism, and I'll give my version of what I think is just how much has actually been achieved here. But that doesn't mean that these lacks or gaps don't actually exist, and I want to talk about what their significance is. There are some things that are partly done, in my opinion. The whole area of mutation, I'm not sure has gone as far as it could do, and it's already been stated that the level of schema or typing is the beginning of a story in terms of schema and typing, a very big welcome beginning. It's a great thing that catalog with multiple name graphs and so forth is actually, is a reality in this proposed version of the standard. So I think this is a hell of a lot that's actually been achieved, and I think to sort of really underline what Stefan was saying, there's a kind of an iceberg effect here. There's what you can see on the surface in terms of the actual content of the specification, but there's a huge amount, both socially and in terms of the standards technical infrastructure that's been achieved here that can then be subsequently exploited in order to develop the standard. And nobody ever thought that GQL was going to be a one-off deal, and that it would be done. I think when we were talking about the project, everybody had in mind that there would be multiple versions, that this would be a multi-year thing. We've got the example of what's actually happened with SQL, and and that's a very, very long story. So that's not a problem. I do think both Oracle and Neo4j are two companies that particularly ought to be given special mention, because the commitment on the part of the individuals, but also on the part of the organizations, is very large to actually make this kind of standards initiative happen. It does not happen spontaneously. And that commitment's been, long-lasting, enduring. It's been a very sort of steady thing. There are lots of other companies involved, like Tygraph and Redis Labs, and I'm not trying to, but I think that they actually should be specifically mentioned. And the fact that SQL and GQL are being managed by the same technical working group is a huge thing. And things like the sharing of the data model, or the sharing of the graph pattern matching language. This doesn't come for free. It's not simple to achieve all of this. It's actually, an achievement in and of itself, that parallelism is there. On the other hand, I just don't think that this is enough. And this is actually not so much a standards criticism. In a kind of way, the burden of what I want to say today is, I don't think that the graph data product producers, the vendors, have really stepped up to what people need to do in terms of enterprise computing with graph data management. There are, various aspects that haven't been addressed within the standard, but that actually reflects something about what you can get in terms of products. And part of my comments here are based on, over the last sort of 9 months, I've been doing some consulting with a major enterprise that has invested very heavily in graph database technology and is very serious about their investment in that technology. And that experience has actually confirmed things that I thought anyway about some of these lacks and gaps and how important it is to actually address them. So there are some things which I think could go wrong at this point, what I would think of as suboptimal outcomes. PGQ could be extended to include mutation of data. I think that would create a fork. A way of doing that wouldn't really create a fork is to take the DML of GQL and allow it to be embedded in some kind of function in SQL, and then at least you'd be able to actually alter a graph using the same kind of syntax that you would use in GQL. But that wouldn't really address the sort of next level, which is the actual issue of graph projection. And I think that if you're going to go really down the line of having full capabilities of graph data management, then the independent language, the GQL language, is really the route to go for. One of the other things that started to emerge in the outer world is people are reaching for what I would consider to be countercultural alternatives to gaps in the GQL specification. And this is particularly evident around Schema. So I've seen a situation when a number of companies who are using products like Neo4j are actually talking about using Shackle as a way of actually expressing schema constraints because they can't get a property graph native schema capability. And to me, that's a really dangerous symptom because it means that in the real world, somebody's going to start embedding something that's a very kind of hybrid approach and doesn't actually build the overall consistent database language environment that's needed here. And you can see other examples of this with initiatives that have come out of the sort of data consolidation, data integration world. How do I pull together a view of all my data? Legend from Goldman Sachs is a sort of interesting example in that respect. And basically what we have here is there is a vacuum, and that vacuum will be filled by something. And so I think that needs to be taken very, very seriously. Overall, in my opinion, if we don't have full power schema and a composable language, the net effect of that will be to condemn graph data management to being a niche technology. You cannot do database management without those capabilities. This is normal stuff. It's just what you get to a certain level with the work you're doing in any serious enterprise. If you don't have these capabilities, you just can't proceed. It feels like a toy. And it has all kinds of impacts on tooling, on things like business intelligence, data modeling, ETL. It's very difficult to sort of, the platform's not there for some of the things that would be required to actually invest in that kind of tooling in this world. So I just wanted to sort of comment on a couple of these aspects in a little bit more detail. For various reasons, people don't like talking about the sort of classic perspective on graph pattern matching. You have a pattern graph, you have a data graph, you do the match, and the result is a subgraph. And it's not completely wrong that people don't like talking about it in this context. What you do have a tendency is some people to sort of, this is what I call, the famous New Yorker view of the world, right? Where there's only 8th Avenue or 10th Avenue, and Iowa, maybe, and China barely exists, and so forth. So you can look at what's going on with pattern matching, and you can say it produces a path set, as it was being described yesterday by Vim, with binding variables, organized as a table. It's tabular output. That's what really matters. It's a tiny little asterisk that says, of course, that is a subgraph underneath there. So in PGQ, what actually happens is you produce this path set with binding variables that Leila is describing, and you select out of it or return out of it. It doesn't matter. That's just syntactic, ornamentation. A table. That's when you really do get a table, right? And that table might just be property values, or it might actually have references to graph elements and so forth. I don't think we quite know yet from what we've heard today when this will happen, but what we really want to be able to do is at least project you know, the result of a match to generate a subgraph, and then that subgraph could be processed by, you know, a future match, and we'd have the beginning of composition. And of course, to really do this, what we need to do is be able to subtract and add graph elements, and to do things like summarization and so forth, so that we can generate exactly the kind of graph that we want to see. We can get sort of full projection capability. And of course, if we could do that, then we can do views, and views are just fundamental to the way in which people do real world data management. That's one sort of aspect. Another aspect in terms of schema, and this is sort of my last sort of theme, is I think that there's something very important emerged out of the work that was done with this graph pattern matching, and that's this ability to encode. It can be done through the ASCII, you know, art, but this ability to effectively encode a graph as joined paths. And if you do that, then you're encoding or expressing in the context of querying a matched subgraph. And if you think about it, you know, you can look at this from the standpoint of saying, well, we have this subgraph that we can express or encode. Those, you know, paths are degenerate forms of a graph. Edges are degenerate paths. Nodes are degenerate edges. Basically, the ability to express that subgraph is a sort of central metaphor or sort of design axis for the way in which not just querying, but the whole of the language could operate. So schema at the moment is being talked about as a union of a set of node types and edge types, and those node types and edge types can be brought into a graph. So we have a schema graph or graph schema, you know, which can map to all conformant data graphs. And if we generalize that, we could actually say, you know, the graph type is a union of subgraph types. And then that allows us to do things, and this is a real world need that I've absolutely seen, to state minimal units of existence, which are more complicated than a node or an edge, to be able to say that, you know, I actually have some clump of information that has to be present or not present as a unit. And it also means that this can be the subject of constraints like keys and cardinalities, and we can sort of view everything as through this kind of notion of subgraphs, and sort of rise to that level and get to a more overall sort of general approach in terms of the way in which we you know, express the different aspects of the overall database language. And I think raising schema to that level and actually being able to operate, you know, thinking about subgraphs as units of data is a practical requirement. And part of that, you know, the subtyping issue that's been raised is sort of also raised around that. Now, I do think that this need for no schema and schema is present, and I do think that the idea of actually having a sort of sliding scale of schema, or the ability to you know, have partial schema as it's sometimes been expressed, for extensible schema, is useful. But I think above all, the actual, you know, the filling out schema, I think, is the most important thing to do first. I think that the partial schema issue can be addressed. It can probably be addressed in interesting ways by vendors, but at a sort of standards level, I think that the real lack is the full scale, you know, power of an you know, fully enforced schema, an SQL style schema. Updates. I just wanted to make the comment that you know, updates are frequently merges because of connectedness in a graph. So a lot of what's going on when you mutate a graph is you're trying to bring a part of it in line with a subgraph type with certain values. And I'm not sure that things have really got to the point where that's been sort of fully nailed. I think this is a part of Cypher that caused dissatisfaction and trouble. You know, and there's more work, I think, that could go on there. But again, I think, you know, this sort of ties in with this sort of subgraph approach to the, you know, the description of the graph and so on. So overall, my summary would be, I think I have a couple of questions and I have a proposal. My proposal is that LDBC should reactivate the community work, particularly around schema, but also around this issue of the compositional aspect of the language, in order to try and preload the standards pipeline. And I think the timing is not bad if we start thinking about the autumn of, you know, of this year, for example, to get things underway again in terms of things like the property graph schema working group, and to try and be more focus and to actually produce concrete proposals that would fit on top of the existing framework that's been created with GQL 1.0. I think that, you know, there is bandwidth and interest in LDBC and in this wider community to actually address some of these things. And I think that that could actually happen in a helpful way that would be in parallel with the, you know, all of the work that's going on the standard per se. I'm interested as to when a very important step, in my opinion, happens, which is that the open Cypher users and implementers, and there are many of them who actually use the Cypher TCK, fork that TCK into a GQL TCK, because I think that it's going to make a big difference if that software capability is actually present as something that people can actually, you know, work off and not just off the very necessary paper standard. And I would say overall, going back to the point about standards and products, these lacks are a challenge and an opportunity for all graph data management vendors. And I think it's sort of across the board. And with some of these features, the level of capability of a product that did embed some of those features would be higher than the current prevailing sort of cultural level of the graph data management category. And I think that is entirely conceivable. It's actually relatively well understood what the kinds of things that would be needed. There's been a lot of thinking about this. I think it's time to try and push the vendors to try and precipitate development in this area, that it should actually happen. I think the users of graph data management are getting to the point where they're numerous enough and they're using graph data for serious enough applications that they actually need this. So on the subject of, on the theme of what Petra said, let's find out what the users want. I can give you chapter and verse on areas of custom engineering that end users are doing that they should not have to do. And I think that it's good for this community to actually push the vendors to step further forward on some of these very core aspects of data management capability for graph.